Hello class, today we are going to start our basic mechanic class, specifically on what 3D and then on springs too as well, right? So analyzing forces like this in terms of distances is more easier as compared to the angles, right? But then all what you need to know is that what anytime we are resolving forces in this manner, and I didn't project again. Okay. Okay, hello class. Today we are going to start our basic mechanics class, specifically on what 3D, right? And on springs. Anytime we are analyzing forces in this form, it's mostly easier because of the fact that analyzing forces like this, all what you need to know is that the resultant of the what the forces or the resultant forces is the force and then what the unit vector, which is the lambda, right? And then we are saying that the unit vector is always what the vector, which is the what the vector. So let's call the vector vector A, right? Divided by what its magnitude, right? So in getting the what the vector, which is let's say the A here, all what we need to know is that anytime we are moving, right? So we have to look at where the force is acting, right? So if you look at it carefully, the question states that what a rectangular plate is supported by three cables as shown. Cable D, B, and then C, right? Knowing that the tension in cable AC is 60 Newton. So the tension in AC is what? 60 Newton, right? Okay. Now determine the component of the force being exerted at what? C. So you are looking at what? This force exerting at what? C, right? Because it's a tensional force, it's going to act in opposite direction to where it is being what? Acted, right? So it's acting this way. So from what? C to A. So and then if you have a force like all what you need to know is that we are always going to consider the distance moving from where the force is coming from to where the force is acting, right? By using these particular directions we have here. So let's look at our main directions. We have what? The direction in the y side, the direction in the x side, and finally the direction in what? The z side. Anytime we are resolving forces such that it is acting in this particular direction we have here, then we are saying that the force is going to be positive. But then if it's acting in the x-axis in the directions we have here, then the force is still going to be positive. And finally, if it is acting in the y direction, then the force is going to be positive. But then if it is acting in the opposite direction to that of the z, it's going to be negative. And then finally, if it's acting in the x direction in the opposite direction to the x, it's going to be negative. Similar thing happens to the what? The negative what? Y direction, right? So this is what we should put in mind when we are analyzing the forces. Okay. So let me start with our movement, which is to get the A. So we are moving to A, right? So we start from where the force is starting from. So from here, you move to this side, right? So if you move to here, we are moving in opposite direction to what? That of the Z. You realize that what? The Z force is what? This way, right? But then here it is moving in opposite direction to it, just like this side. So we are going to get it in terms of one negative, and the distance is what 360. So we are going to get minus what 360 what z, right? Okay. Now from here we moved from here to the center, and then don't forget we are moving in opposite direction to the x-axis, right? So that is going to give us what negative what 450. The distance is 450 x, and finally we move from the center to the where the force is acting, of course A. So don't forget we are moving in the right direction, which is the positive direction. So that will give us what? Plus 400 and what? 80. Okay. So if you want to find the what? The the resultant, we know is always going to the unit vector is going to be the vector divided by its magnitude, right? So let's look at the magnitude of what? A. Okay. Okay. So the magnitude of A will be what? The square root of what? The square of what? The individual what? Distances. So that will give us what? 360 what? Squared plus what? 450. You can make it negative, but then it's still going to cancel out. That's why I'm writing the positive. And then finally we have what? 480 squared. So that will give us what? A resulting value of what? A will give us 700 and what? 50, right? As what? Distance. So let me make it meters. I don't know the unit that was given. So you can make it units. Okay. Now, so let's look at the individual forces. So our force FR will be equal to the force itself, which is 1618, multiplying the unit vector. So we have minus what? So let me take it from the what? The x, right? Minus 450 what? Divided by what? 700 and what? 50 x, right? Minus 360 all divided by what? The 750, the individual unit vectors. Of course, is the z-axis. And then finally we have what? The y-axis here, which is plus what? 480 divided by what? 750 in the y direction, right? So if you multiply, we are going to get a resulting force of, so we can make it in terms of what? Jijk. Of course, it will work. So that will give us what? Minus what? 36 what? In the what? The I direction. And then plus what? 38.4 in the J direction. And then finally we have minus 28 minus 28 point what? 8 in the K direction. So this is basically our resultant force. So assuming we are told to find the magnitude of the resultant force, we just need to square the individual forces we have within the what? Within the what? The resultant force, and that will give us the magnitude. So thank you, and then we will meet in our next class. Bye.